Hello and welcome to my final project presentation. I chose to do the first project because I'm a Reddit user and I've interacted with a lot of different subreddits, so I thought this was an interesting application of what I've learned in this class to something that I like doing in real life. And for this project, I'm aiming to build a random forest classifier to predict symptoms of depression from real Reddit text data. And we'll be doing this with two different methods of creating linguistic features, LDA and Roberta embeddings. And this project will follow the methodology outlined from this research paper that was given to us. So moving on to a quick overview of the code. We have pre-processing where I had to create a symptom map for the subreddit to the actual symptom. We have dataset generation, where we'll be filtering out data that is not useful in our analysis. And we also loop through the authors and find their control posts. So this means that we'll need to look at the earliest post by an author in the depression dataset, and then we have to select posts from the main dataset that are 6 months before. We also have tokenization, which allows us to better see the individual tokens of the post text that the authors have posted. And then we have stop words, where we're able to find the top 100 words from both the control and depression data sets. And then we get to loop through the 13 symptoms and create separate data sets for them. These are saved into individual data frame files, and they'll be useful later. It's actually 11 symptoms because during this process, I discovered that 2 of the symptoms had basically no data, so we can just remove them. So once this is done, we can plug this all into our LDA and Roberta implementations. So for LDA, it's pretty simple, just importing LTA multicore and plugging in our preprocessed data frames. For Roberta, we'll be touching upon this later, as this was the most challenging part. And once we have LDA and Roberta ready to go, we can basically have that train model and the Roberta function. We plug in the individual symptom data frames that we have. And then when we run it in main, we compare it to the target labels. And then once this is done, we'll be getting results from the classifier. And you can see some of the examples of what the results will look like. And then we compare these testing scores to the ones that the authors found in the paper. So touching upon the most challenging part of this project for me was definitely the Roberta embeddings. And this was due to the difficulty of optimizing my code so that it wouldn't take up all the RAM of Google Colab due to Colab limitations. So for a quick step-by-step run through of the code, we load a pre-trained model tokenizer from Roberta. And then we have this tokenized text function, which takes this tokenizer and gives us an output that we're able to plug in later. We also have to take the average across the 10th hidden layer of the first dimension. And the reason we do this is touched upon in the paper, sort of. So basically, Roberta models have multiple hidden layers, and we are focusing on the 10th layer here just to match what the researchers did in that paper. And the mean function allows us to compute the mean along that first dimension, that layer. And after that, we load a pre-trained model from Roberta, as the researchers did. And we can then apply the tokenized text function to the input data frame. So this data frame is going to be the individual symptom data frames in the main function, but the tokenization is really important. And then after that, we get to extract embeddings for each text. And this is basically done through passing the tokenized representations, calculating the average embedding across the 10th hidden layer, and then appending it to the average embeddings list, converting this into a NumPy array as well. And the main difficulty was, again, trying to optimize this code so that it could run given Colab's limited computational resources. And that's why I had to change a lot of it so that I could use CUDA, and that's what this refers to. And I used CUDA because it allows me to use the GPU instead of the CPU during my running of the notebook. So if you change the runtime type, you can see that there's a few different options. And originally I was using CPU for everything, but once I got to Roberta, I ran out of RAM immediately. And once you connect it, you can see the RAM here. It goes up to like 12 gigabytes around. And I had to change it to GPU because a few homeworks ago, we also got to use the GPU, and it kind of explained why that was more effective in certain cases. So GPU was definitely more helpful, and I never really hit that RAM limit when I did that. I just had to change my code. But this was difficult because I also had to switch accounts to my personal Google account as I ran out of credits on my school account, and I couldn't buy any credits for some reason. So it was just a little bit more annoying to have to import everything over to my personal Google account as well. So that was my main difficulty, and we'll be touching upon some of the ethical considerations of this project. I think that ethical exploration is really important for this project because it centers around sensitive discussions on Reddit. And I think NLP applications in mental health research could hold the promise of pretty significant benefits, particularly in early symptom detection and support. they are also accompanied by ethical considerations that require careful attention. And first and foremost, I think informed consent is a cornerstone of this research because we're working with some very sensitive and personal data related to mental health. And privacy as well is extremely important because discussions about depression and these topics are very personal to people, and they definitely would not expect their posts or want their posts to be used for public research purposes. And I am a subreddit owner of a community with 2.6 thousand members, and there are times when I've seen some pretty personal things on here. So I kind of understand how important it is to keep these things private and really get people's consent before we use them. Furthermore, I think responsible data management is paramount because we have to establish security protocols and ensure that these things don't get leaked out to malicious parties. And finally, I think that we should make careful consideration of bias in the data and the resulting models, because it's possible that data from a single online forum can carry inherent biases, such as underrepresentation of certain demographics or overrepresentation of a certain type of user. So overall, I think that NLP is promising, and if we develop further upon it, it can be very useful for identifying if people are having these kind of symptoms and if they need support early. But we have to make sure that we're still following all protocols and being diligent when dealing with people's private matters.